Hello everyone. Today we're going to talk about something different from all of our speakers. We're not going to talk about hope, and we're not going to talk about if humanity is doomed by Mr. Valent. Today we're going to talk about infinity. Infinity is something as the greatest in the universe. Like it could even make 7'1" Shaquille O'Neal look microscopic. Like what even is this? Jokes aside, infinity is an interesting topic that goes with a lot of subjects, not just mathematics, but also in philosophy, physics, and even religion. We're going to talk about infinity in terms of mathematics so you guys don't have to experience an infinite amount of boredom. So let's go into the basics. Infinity is often called lemniscate. It originates from the Latin root lemniscus, and it has its own symbol. Lemniscus means ribbon, and the symbol is shaped like a ribbon. The number itself, infinity, has its own Latin root, which is infinitas, which means boundless, and the number is boundless. And I could have just explained infinity in the concept of college levels. I could just created a boring 15-minute speech about explaining infinity in college levels, but just for the sake of the audience and also me, I don't want to watch 15-minute videos of professors explaining this. Yet it could be as simple as a sheet of paper. This is called a Mobius strip. This Mobius strip figure is accomplished by using a strip of paper and twisting it and then putting it to the opposite end. And it has one side and one edge. As you can see, the tennis ball can roll endlessly. And this is actually seen in factories. The rubber is proven to have a longer lifespan since it wears out equally on both sides. There are a lot more ways infinity applies to our real life, and since you guys are interested now, let's go in deeper. And don't worry, we're going to talk about addition and subtraction. So this is the basic 3 beliefs about infinity. Infinity goes on forever, infinity is bigger than the biggest number, and infinity is bigger than anything we can think of. These statements are true, it can also be false at the same time. And how can that happen? Let's look at it by approaching it with simple math equations. If you add 1 to infinity, it's still infinity, right? Since infinity is the greatest number, it wouldn't make any change. And if we subtract infinity from both sides, we are left with 1 equals 0. And this is false. Our second equation, if you add infinity to infinity, it's still infinity. That means 2 infinity equals infinity. And if we divide infinity by both sides, 2 equals 1, which is also false. Last equation, if you multiply infinity by infinity, it's still infinity. And if we divide infinity by both sides, then we will come to the equation infinity is 1. And infinity shouldn't be as small as the number 1, right? So what has gone wrong? We had assumed that infinity is an ordinary number. Mathematicians have spent ages to work with infinity, but we have still come up to a lot of results. But however, infinity is still not an ordinary number, and we should be careful working with it. So why do we have to care about something that we don't know even exists? Suppose you have a graph here. How are you going to calculate the area of the red area between line A and line B? Are you going to use circles? That's not going to happen because you see a lot of red area left. Let's use rectangles. Even though you see a little bit of space, red area left down there, it's still okay because it covers a wider area. And what if you want to get the perfect area of the red space? We could just infinitely divide the rectangles, right? You can see that the red area is diminishing. And the math behind this is integration. We are dividing the rectangles infinitely to match the slope of the line from each point, so we can get less and less area left out. And this might seem nerdy because you won't use AP calculus in real life. So let's talk about cardiac output. Cardiac output is the volume of blood pumped. So with this number, you could calculate if a person is prone to heart disease or not. And the math behind this is integration because you're calculating the area under the line, under the curve here. So now it is interesting, right? Integration is saving lives, and integration is made by infinity, so infinity is saving lives. And this might not seem interesting, but let's go in deeper. And I'm going to end this speech with a paradox. Suppose you have a hotel with an infinite number of rooms. And that's my friend Peter trying to ask for an empty room. It could be accomplished by moving a person from room 1 to room number 2, 2 to 3, 3 to 4, like that. So you have an empty room in number 1. So Peter is inside the hotel successfully. one day, a bus with an infinite number of people show up, and they want a room. But that's still approachable, right? Infinity plus infinity is still infinity. And we can accomplish that by moving person in room 1 to room 2, 2 to 4, 4 to 8. So just multiplying the room number by 2. So each people could go in the odd number rooms. So 1, 3, 5, 7, and 9. Okay, that's still basic because infinity is still unapproachable. And here's an infinite amount of people approaching to the hotel, but it is different this time. Each person has a name consisting of infinite numbers of A's and B's. So a person can be named AABBBA or BBAA or BBBBBBB and so on. And a person will be definitely left out. What does it mean that a person is left out? There's more people in the bus, right? So let's prove that. Let's line each names to the rooms. So room number 1 has a name of ABBA, ABBBBBB from room 2, BBBB and from room 3, and so on. And let's get the diagonal. So first letter from the first name, second letter from the second name. So we're going to get with ABAB, ABAA. And if we convert A's to B's and B's to A's, it will lead to that small name there. And this name will be definitely left out. It's because it is one letter different from room number 1, one letter different from room number 2. The third letter is going to be different from room number 3, and so on. It's going to mismatch with all the infinite rooms possible in the Hilbert Hotel. So what does that mean? The number in the bus has more people than the rooms in the hotel, but there's still infinity, right? It means that the infinity in the bus is more than the infinity in the Hilbert Hotel. And this may not seem interesting, but this has sparked an idea among computer scientists about what you guys use every day, your phones. Your phones has actually sparked an idea among computer science by the notion that some infinities are greater than other infinities. There are infinite more ways this is the phone. Okay. There's an infinite more ways infinity approaches to our real life. This thing has unlimited potential, and we are still finding more about it. But it is still worth it to venture bravely into the unknown. Thank you.